Okay, let's get started. First thing I'm going to do is check to make sure my mic is working. Might have a little feedback because I do this in the most unprofessional way. Bring up my phone and check it. Okay, let's get started first. And it seems to be picking up okay, so let me Good gracious. Okay. I got to figure out my setup again. I think I've got it laid out. It took me about 30 minutes to get it where I wanted it to be tonight. I've got a lot of stuff going on now that I'm streaming, and I'm not streaming to 2 different locations because I'm so daggone popular that I need to. But I've decided to go more to the YouTube than Twitch. But I am streaming to Twitch, continuing to stream to Twitch as well. So this is online office hours for my statistical class on Wednesday nights. And we are going to talk about a few things as listed as you see up here. And I'm also going to talk about a few other topics. We'll talk about some measurement scales. We'll talk about nominal. What else do I want to do? Ordinal. We'll talk about mode to some extent. I dismissed mode last week in class. But I shouldn't have, because there's more to mode, and I should have thought through it before I dismissed it. But we had a shorter class. It was the first class of the summer session. So I went a little bit shorter, and we just covered a little bit of stuff and then moved on. So I got my big head on one side. I got this on the other. I'll probably switch it in a second so that we can, so you can see more of what's going on instead of my big head in the way. So let's get started. What we're going to talk about tonight is measures of center. So we're going to talk about mode for just a second, and we're going to talk about mean. I'm not going to talk about median tonight. We'll get back into that tomorrow, but I'll talk about mean, and I'll talk about measures of variance computationally. I want to talk about these computationally. Sorry, my background music is clipping into me. Hey, Victoria, good to see you. Thanks for stopping by. I appreciate it. And I see you in here, and I'm not sure. There you are. I see you in YouTube. So yeah, tonight I'm just going to talk computationally about mean and variance. And then, as I stated before, nominal and ordinal, I'm going to talk about a little bit in the sense of measurement scales. And what was the last thing? Mode to some extent. Okay. And where was I actually going to go with mode? Oh, I know where I was going to go. Okay, so let's start off with this. So I've got these notes up here, but this is nothing major. And let me just switch so you don't have to see my big head up here. I'll put my big head down in the corner. There we go. And I don't necessarily... Let me switch something. I'm sorry. Take 2 seconds to do something that nobody's really paying attention to. But I'll do it anyway. There we go. We'll do this. Yay. Put that across the bottom. That way, if anybody scrolls by and they wonder what this guy's talking about, especially if I don't have anything up on the screen at the moment that they stop by, then we'll be able to correct it. I am looking, just because I'm trying to get consistent with this and what I talk about at the beginning of the stream. I want everybody to know what I'm using to stream with. I know some of the professional streamers are always talking about their daggone computers and their nice streaming software. I have a 2015 model Mac, 27 inch I think it is, which is fantastic. It's just 10 years old, that I use to stream. I use Restream to do my streaming, which is more of an overlay than, say, OBS, where you have to mess with stuff to some extent. And I stream with Restream to Twitch, which is where I used to do all my streaming for class. And I also stream, I've just started streaming to YouTube. So this is my second one to YouTube this semester for summer term. So here's where we go. So let's talk for a second, not about the Cleveland Cavaliers from 2009 and 10, but let's talk about mode. So I was dismissive of mode in the last class. In other words, we talked about measures of center generally as a topic that we're moving into, because I want to talk about the structure of it, and I wanted to talk about the symbolism and what usually throws people off as far as a statistics class, vocabulary and symbolism. And people don't go into enough detail with it. Hey, Tiante, good to see you, bud. People don't go into detail about it when they're teaching the class, and they just kind of leave it hanging. And I was, unfortunately, dismissive on mode. And just a reminder, thanks for stopping by Online Office Hours. I make note when folks are here, and it helps me keep up with it, and I always appreciate it. But at any time, the great thing about Online Office Hours is if you want to eat supper while you're hanging out for a few minutes, that's fine. If you want to do other things, put me on mute, and every once in a while just pretend to be involved and send a, hey, I'm here, what's going on? That's fine too. This is for you, and there will be a video that's left up on YouTube and on Twitch if anybody needs to run it back. So, okay, back to mode. So I was dismissive of mode. So I talked about multimodal situations. I talked about graphing situations, not in any detail. And I said, I really don't do a whole lot with mode after this. But you could do a lot with mode. Like you could talk about something that would be categorical, like we could talk about, let's just say, let's go nominal. Let's talk about a level of measurement in the notes that I gave out last week that you're responsible for to regurgitate this week on a vocabulary quiz. Let's talk about a nominal level of measurement. If I talk about types of soda, right? So I could say Pepsi. I could say the best one ever, Mountain Dew, although it's bad for you. I could say Coke. I don't know, I could go diet. For each one of these, I could go diet. Well, let's just put a few more up here. Let's go Tab. Everybody loves Tab, maybe. So you got 5 sodas up here that are up here. These are nominal. There's nothing to this. Like, in other words, if you look at just the definition of it, they're just simply categorical, right? There's no real order to this unless you place order to it. And that's what I want to talk about. So when you talk about mode as having some kind of importance, it had, hey, got 3 people here. I'm excited. I'm stoked. This is like a record for me. You go on streams, I got 6,000 people. I got 3 and I'm excited. Thanks. So this is nominal, but it could be more of a variable that you could quantitatively define, right? Because I could ask in a room of, say, 300, I could ask in a room of 300 for you to vote on your top drink. What is the drink out of all of these that you like the most? And maybe Pepsi gets, 110. And Mountain Dew gets 220. What is that? 3? I don't know. I'm just going to go with a number. Coke gets 25 because it's terrible. Diet Coke gets 10. And Tab gets 1. Let's just go with that. So I've got 220, 110, blah, blah, blah. So let's say for a second, though, that Tab, people really like it, like they do Mountain Dew. I don't even know if they still sell it. So you might have Tab and Mountain Dew as 2 drinks that are at the top of the scale. In other words, the mode of this, what started out as a nominal set, is now Mountain Dew and Tab. So there is some relevance to mode in the sense of sets. And you could graph that. You could graph it in a histogram, and you could just have, I'm going to try my best to draw a halfway decent histogram. This is not going to be good, but I'm going to try it anyway. I'm going to go Coke. I'm going to go Mountain Dew. I'm going to go Tab, Diet Coke, and Pepsi. Which I think Pepsi's better than Diet Coke if you're going to drink a soda because it's got more fizz to it. Coke to me just tastes like it's flat. But that's just me. I'm not hating on Coke. Just saying. Okay. So you got Coke. Coke had how many? I just made up a number. Didn't even go with the original that I had. So I got here 25. And then you've got Mountain Dew that had 220. That's going to be something like that. And then Tab also had 220. What a great drawing. Diet Coke had 10. And Pepsi had 110, which is right about half of there. So you could graph it. So the nominal values that you started with, the ones that were just categorical, like eye color or anything that you could list, and they have no real order to them, now have an order to them. Now, I didn't write them in order in the bottom, excuse me, but you could order them from lowest to highest. You could go Diet Coke, Coke, Pepsi, and then Tab, Mountain Dew, if that was the way it worked out for this particular population when they choose out of these 5 categories which drink, or out of these 5 drinks, which one they like the best. That's my spiel on mode, and I felt bad. When I'm driving home, sometimes I'm reflecting on what some of the crazy things I might have said. And one of the things that I always say is that I don't do a whole lot with mode, but I did want to bring it back up and just say that you could, in some situations where it doesn't seem like it's important, it could be. So there we go. All right. Let's talk for just a second about one more nominal category. Let's talk about just nominal in general. So, Which one am I going to choose? Let's just do eye color. That's like rolling dice or messing with cards in a stats class. You're always going to come across it, right? So let's just go nominal, measure, measurement scale, right? So there we go. Okay, so let's look at eye color. So eye color could be brown, it could be blue, it could be green. I don't know what other eye colors there are. Hazel, and all in betweens, right? There's variants of all of these, but just out of the gate, let's just go with these four right here. Can you put these in order? Not really, not based on just the colors themselves, so that's why it's nominal. These are variable, but they're simply categories. So eye color would be considered like a categorical variable, so to speak. Sorry, I'm looking around. I got my screen and I got my notes and I don't have my glasses on, so it takes me a second sometimes for it to adjust. But this is just a nominal set. Now let's switch gears to the second one, and I will not stay on this very long, but I did want to cover at least a couple of these, and then tomorrow night I'll talk about all four of them. Last week I just gave the notes, but you probably looked at the notes and said, yeah, I got this, and then we started going over it. I'm like, how am I going to remember all this? So if you're talking about an ordinal variable, let's talk about a weightlifting contest. So let's go weightlifting contest. And in the weightlifting contest, you could have a first, a second, and let's just say a third place. Because you can have a first, second, third, these could be ranked and put in some kind of order. They can be put in some kind of order. So it starts off, I don't know, anything that you can assign some kind of quantitative value to typically is going to fall into the ordinal measurement. So you can put these in order. If you were looking at, if I had a bunch of my friends in front of me, like say 5 friends, and I said, okay, y'all get in order from shortest to tallest or tallest to shortest. They were just my friends before, Billy, Timmy, Sally, whoever. And now that I've put them in order from shortest to tallest, I can now rank them, right? And I can look at them a little more quantitatively because that order is important. Whereas with nominal, brown, blue, green, hazel, that order's not important. I wrote brown first, but I could have just as easily put blue first or green first or hazel. It wouldn't have mattered. So just a quick overview of nominal, and ordinal. And I'll leave it at that. Okay. So what I really wanted to do tonight, and by the way, y'all, I do appreciate you coming on here tonight, and I can't keep up on, I look at YouTube up here, that's why I keep glancing up. I have YouTube up there, I have Twitch down here just to make sure I don't miss any comments or anything. Before I get into the computational side and a little bit of the calculator with measures of center and variance, just another computational overview, so to speak, before we go into tomorrow. I can pull folks in using the software like if I had to. Like if we really got down and deep into a subject and you were like really confused and typing out things just doesn't work for you, then I could bring you in, you could talk through it. You wouldn't have to show your face if you didn't want to show it to the World Wide Web. I don't care, so I just do it. But you wouldn't have to show your face if you didn't want to. If you did want to, it's fine. If you look, nobody's on the stream. Just you guys and me. So nobody's really looking. But I could bring you in and we could talk through whatever issue you were having or whatever questions you were having. So that's actually a beauty, in my opinion, of the online office hours. I feel really good about that. So let me backtrack just a second. We'll get back to the 2009-10 Cleveland Cavaliers. But this is really the gist of what I want to talk about tonight, right here. I talked about mode. I talked about measurement scales in the sense of nominal and ordinal. Just kind of a couple of examples. But really what I want to talk about is measures of center and measures of variance. And I want to go and talk about these a little bit and talk about why they are what they are and how they work, but mainly how they work. Oops. Here we are, Cleveland Cavaliers. Before I get that, I'm going to erase all strokes from that slide. There we go. I'm going to erase all strokes from this slide. And now I'll go back to this. So the heights of the 2009-10 Cleveland Cavaliers. So just as mentioned in class the other night, you have found averages over the years in a lot of the algebraic classes or classes that had a statistics strand in it. You found averages or means before, I'm sure. You maybe worked with different manipulatives or whatever to do that, or you may have just done it on paper. So the fact that you can do it is great. But I do want to emphasize the fact that we have a formula for this for both population and for sample. Both are exactly the same, even though they're written slightly different. I talked about that in class the other night. Let me just review that real quick. You see it here, and let me just put it together here, because what I want to do is I'm going to pretend, I'm not going to pretend, I'm just going to say this is our population. So our population is all the players on the 2009-10 Cleveland Cavaliers, right? So if it's a population, then I'm working with mu that represents mean. And the formula is summation of all the x values divided by how many there are in the population. Again, you've done this, but let's see how it sets up mathematically when you apply the formula to it. I've got all these numbers. So this is 74 inches, 78 inches, 81 all the way to 81 at the end down here. So if I'm going to take the sum of all those and then divide by how many there are, then I'm going to take, and it doesn't matter what order I go in, because commutative property states I can go in any order, but I'm just going to go to left and right because that gives me a little bit of a pattern that I can follow and catch myself if I look down and then look back up. Hope that makes sense. Well, that's terrible. Let's get this. So I got 74 plus 78 plus 81 plus, now at this point I'm going to put some dots up here. Now these dots are going to represent the addition of all those numbers in between, because as you notice, I'm about to run out of room here. So I'm about to run out of room at the end of my iPad that I'm writing on. So I go 74, the first one, plus 78, plus 81, and then I'm going to go dot, 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 plus, and I'm just going to put the last one, 81. So there we go. All divided by however many there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 15. That's it. I know that's not rocket science, and I know it's not magic, but I just wanted to lay it out for you because I want to talk about some of the classification schemes. We've got this formula right here. I don't like that color. Time out. Let's go here. We've got this right here, which is our formula. We've got a Greek symbol right there, a Greek symbol right there, and then we lay it out right there. So I just want you to see how it's laid out, because when we get into some more advanced formulas, we're going to do this exact same thing, just with some more, not exactly rocket science, but a little more rocket science than this in their form. Okay. And I don't even need to work this out. I think you get the gist of it. I can add 74 all the way up to 81, divide by 15, that's the mean. We'll find this in just a second because I'm going to find it on the calculator, if you can bear with me. If you drop out, by the way, if you go get supper, if you do stuff like that, no worries. Please don't feel like you're stuck in here for long periods of time. But the video will be up afterwards if you want to come back and kind of review any of the things that you missed. And again, I can't emphasize enough, I really appreciate you guys stopping by. My wife jokes with me every time I say I'm streaming. She says, okay, tell everybody that's not on there I said hello. I'd like to tell her that I had a bunch at some point. Okay. Where am I going? All right. Let's talk about, we're working with a population. So let's talk about the variance formula. Let's find the variance of this. And I'm not going into huge definitions of variance. We'll talk about that in class tomorrow night. Tonight, I'm just going to break down the form for it. So if I'm working with a population, I am working with this formula, which is lowercase sigma squared. Uppercase sigma is that, by the way, summation. We're now working with lowercase sigma squared, and that is equal to the summation of all the x values, one at a time, subtract the mean squared, divided by how many there are. That's not that much different than the previous, right? It's a little more complex, a little more to it, but it's not that much different. So what I'm going to do is, I guess I can go across here. if I'm looking for the summation of these values, and remember, the values were 74, 78, 81. Let's start with those three, 74, 78, 81. I'm just writing those so I don't forget them. First three values of our set. Those are the heights of the 2009-10 Cleveland Cavaliers. Hey, thanks for stopping by. We have 4 people in here. Yay. Thank you. All right, 74, 78, and 81. So here's how it lays out. And I'm actually going to switch. I'm going to go right below my formula. I'm not going to go next to it because, as you see, I'm going to quickly run out of room. So let me bring this form right here down here. So I start with, and again, I go left and right with the numbers. It doesn't matter what order, because commutative property, if you remember from algebra, dictates that I can go in any order, add them up, and I'll still be the same. Same thing applies here. But I'm going to go left and right so there's a clear pattern so I can keep up with it. So I'm going to go with the first number, which is 74. So I'm going to go 74 minus, timeout. Let me find the mean. I mean, waste your time so you can watch me type on the calculator. 74 plus 78 plus 81 plus 87 plus 81 plus 80 plus 77 plus 73 plus 80 plus 85 plus 78 plus 80 plus 83 plus 75 plus 81. 1193 divided by 15. I got 79. So when I get to the end of this, I get 79.5. We'll just go to one decimal place. So 79.5. Okay. Flash forward to here. And I'm going to go. I know that the mean is 79.5. I'm going to need that. So I'm going to go this 79.5. Then I square all of that plus, what's the next number? 78. 78 minus 79.5 squared plus, the next number is 81. Subtract 79.5 squared. And now I can take these off at the side. Now notice, this is all going to be divided by 15, by the number in the set. However, I'm kind of running out of room, so I'm going to do the same thing as before, plus dot, 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 plus, they should be in a straight line, but I've run out of room here. The last number in our set was 81. So I'm going to go 81, subtract 79.5 squared, and then all of that divided by 15. So I take the sum of all those situations, 74 minus 79.5, whatever that becomes, square it. Plus 78 minus 79.5 squared, plus 81 all the way down the line with every single number in the set, and then divided by 15. That gives you your variance. And in variance, you're trying to see how far they vary from the center. You're just trying to see how much variance there is. Again, I'm not going to completely define that tonight. I want to talk more about the computational. Let me just leave it at that. I don't know if anybody has a question. It's okay if you don't. I'm just going over a few things. Like I say, this video will be up there. But let me move forward for just a second. Okay, lost my train of thought for a second because I was going to switch gears to the calculator. I think I will. I think I'll switch gears to the calculator, and I've got all of these numbers. I want to see if they'll store. No, they're not going to store. Maybe they will. Yes, they will. To L1 in my calculator. No, it says quit because I did it after the fact, like a dummy. Okay, it's fine. So what I'm going to do is I'm going to go to the calculator. I'm going to work with a much smaller set. So anyway, as you see with the Cleveland Cavaliers from 2009-10, we can work with the formula to find the population variance. We can work with the formula here to find the population mean. And now what I'm going to do is I'm going to write the formula for mean again in terms of calculator uses. Then I'm going to switch to the calculator and I'm going to show you what I'm talking about. we're going to use the cells like a spreadsheet in the calculator to figure out some things, because your sets may be more than just 15 numbers. You may have 1,500, and with 1,500 you're not going to want to go through this for 1,500 of these computations. You're going to want to do some stuff using some technology, because when we get to the end, we're more concerned with what the variance is or what the standard deviation is, and in what context we can use that to present to whomever, so we can make some decisions on some things. And we'll talk about that kind of stuff in class as well. Let me do this. Okay, so I'm going to go back to the formula for mean. So the formula for mean for a population is mu equals, wait a second. Yeah, I used the right thing. Mu equals the summation of all the x's divided by n. No problem. We know what that is. It is x1 plus x2 plus dot 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 plus xi, whatever that I is. There may be 100, there may be 1,000, and then divided by how many there are. Okay, we know that. That's no issue. If I were going to do this on the calculator, what is it that I'm adding up? Well, on the calculator, and I'll show you in just a second. On the calculator, if you go to the stat button, you may not have it in front of you, so this may be meaningless for the time being. But if you click the stat button, you come into the cell sheet, which is nothing more than a spreadsheet in the calculator. And you've got L1, L2, L3, as far as you want to go. And it stops at a certain point, but you could add, change those names, whatever you wanted to do. Typically, as a student in statistics in a class, you're going to put your numbers here in L1. So L1 is basically your X values, right? So if I wanted to find the sum of those X values, this is tough to talk to. I can go to second list, go over to math, and do sum, but without showing you. Let me just put a set in. Let me just get out of this daggone screen and go to the calculator. So let me switch this. Let me see how good it's going to like this. It may get all white screeny and stuff. I'm going to... Oh, I know what I do. Never mind. Time out. Poof. There we are. And I got a bunch of junk up here. Oh, shoot. There's a lot to keep up with this stuff. Some of these folks who stream all day, I know why they stream all day, because that's all they can keep up with. And there's a lot. I'm not downplaying it. I'm just saying. We got this and this and move to this and all this other mess. Okay. On the calculator, you see this button right here, stat. That's what I was talking about. So I'm going to hit clear. This, by the way, is Calc 84. I bought it on Apple for about $4.50 or $4.99 or whatever. It is the same thing as a TI-84, but sometimes it looks slightly different. And I'll try to walk you through that and explain. If you have your TI in front of you at some nights, if we're working just calculator, then you might see it. If not, then it might not make a difference. Anyway, if you go to Stat and go to Edit, it's going to bring you to the L1, L2, just like I was talking about a second ago. And hopefully you can see this. If you're on your phone, I don't know how good this shows up if you just kind of got your phone up there. It shows up okay on mine. Probably better on the phone. You can see it a little closer. But on the computer, it shows up larger. So I've got a set here. I'm going to put even more. I'm just going to put a couple more numbers here. So I'm going to put 89, enter. 36. I'll leave it at that. We don't need that many more numbers. If I want to find the sum of this, to find the mean, if you look right above the stat where it says list, that's what I want to go to. I want to go to the second function of the stat key. If you hit second right here and then go to stat, there it is. And if you scroll over to math, you'll see a whole lot of different functions. Do I want to find the minimum in that list? Well, I don't really need to, because I only have like 5 numbers. The maximum, the highest number? No. The mean. Let's find the mean of it. And I just made a mistake. I have to quit first, and you see quit above mode? Daggone it, Mike. I have to go second mode. Now I can go to list. Because what the calculator is trying to do, it was trying to fit it into a cell. Instead of exiting out first, the calculator thought I wanted to find the sum of something and put it in the cell. which is not what I wanted to do. So now I'm at math. I go to sum, and I go to L1, which is the second function of the 1 button. So I go second, 1, and brings up L1. I don't have to close the parentheses. I hit enter. There's the sum. So there's the sum of all those numbers in L1. So if I have a large list of it, the list I had was not large, but if I had like 1,000 numbers, whatever, I could add them up by just using the sum key right there. Now let's talk about one that is let's talk about finding the variance of the same set, one that's a little more complicated than what we had before. So if you remember, the variance for a population, there it goes. The variance for a population was lowercase sigma squared equals the summation of x minus mu squared divided by big N, right? So we talked about that a second ago in the slides. So I just place it up here. I got to go back to the calculator, so I'm going to remove this down. But we're going to do this with calculator lingo. In other words, what are the x values? Aren't they just the ones that are in L1? They are. And what is the mean? Well, we'll talk about that in a second. But basically, you're going to switch. I keep talking about it in a second. Everybody's like, dude. Sigma squared equals the summation of L1. So every time, so it's just going to pull from L1. It's going to pull from the first one, the second one, the third one, and do a summation. Subtract the mean of L1 squared divided by N. Now, I hope you caught that. I'm only working with L1. I'm still finding the variance. I just have a couple of columns to work with. I'm going to do this, then I'll stop for the night. And again, I appreciate folks stopping by. Man, it's been really fun having people in here. Even though there's not much interaction, but I get a little bit. I'm just excited. All right. Let me close out of this, and let me show you what I'm talking about here. I think I can click this from here, actually. I think I can click it from my iPad. So anyway, I'm going to go back to stat. Yes. And I'm going to go to edit. And there it brings it back up. So there's my L1. 98, 32, 65, 89, and 36. I want to find the variance of this. Okay. So I'm going to scroll over to L2. And notice that I put my cursor on L2. On L2 right there. And I'm going to put a formula there that's going to fill in down below. So the formula I'm going to put there is my variance formula with the exception of the what I'm dividing by. So I'm going to put parentheses, second L1, subtract, second list. I haven't shown you this. Everybody's like, what is he doing? Mean, second L1, parenthesis, and then squared. Hit enter. It's going to fill in down below. Ta-da! So let me explain what this is. I might just stop here because this is a lot. Oh yeah, there's so much of this. The only trouble with the TI-84, in my opinion, is that it's old school syntax, right? We're used to, like even my 2015 Mac is pretty upgrade. It can't upgrade anymore because it's old. But it's pretty upgraded in the sense that it's an overlay and I don't have to program stuff in. And I don't have to put in like DOS commands or anything crazy. This is more like DOS commands where you got to know the syntax. Once you know the syntax, pretty easy. Pretty easy to work with. So anyway, I will finish this one out. But let me do an overlay and just talk about this for a second. So what did I do? So I took this data and I found the mean. Oh, shoot. Undo that. I found the mean of L1, right? I used that within my formula itself. And again, back to this, sigma squared equals the summation of L1, subtract, and I put the mean, I'm running out of room, daggone, squared. So this is the part that I just worked with. I didn't do anything more. So I have this first number right here, this This very first one right here, this 0.15, no, 1,156 that I've got there. Sorry, I had to stare at it for a second. That I've got right there. That, what I did to get that, or what the calculator did was, it took that first value, it took 98, subtract the mean of L1, and squared it. And that's how it got 1,156. Dot, dot, dot. So all I have to do now is get the sum of those, which is what we've been getting every time. Get the sum of those and then divide by how many there are, which is just 1, 2, 3, 4, 5. So I will finish this out. So let me go to the overlay. And let me go second quick, as if I don't, it's going to try to put it in there. And then I'm going to go second list. I can hardly see this. I think that's sum. Yep. I'm going to go to the sum of L2. Enter. So there's that sum. And I'm going to divide by however many there were. I think there were 5. Enter. So my variance is 718. Now what that represents is what we'll talk about in class tomorrow night. In and of itself, by itself, sometimes the variance is way off the mark and nobody would understand where it relates to the set. We're going to talk about that in sense of maybe we have a second set or a second sample that we're working with, or second population. Okay. I don't know if any of this has been helpful tonight, but I hope it has. 1, 2, 3. Yeah, I had 5 numbers, so I remembered correctly. So what we've done tonight, let me go back to, here it is. Oh my goodness, I don't know. Here we are. This is the function of having a 2015. You see how it just goes bright? It doesn't know what to do, and then it brings this up. Okay. So just to reiterate what we did tonight, we talked about mode and we talked about some measurement scales. I talked about nominal and ordinal, just in the sense of a couple of very simple examples, classroom type examples. Computationally, I wanted to cover measures of center, which I think everybody in class would be overly familiar with, and then measures of variance in the sense of how it works out if we're working it out piece by piece, and then how it works out if we go back to the calculator and use the calculator cell sheet to work through it. And certainly there's different ways to skin that cat, but I want to give you all the nodes that I can so that when your brain starts formulating how to work the problems on an assessment or in real life, wherever you're at, it'll have some nodes to pull from. So I'm trying to give you several different options to go to pull from, to say that about 14 times in a row. All right. That's all I've got tonight. I think I just wanted to go over a few things. I wanted to do a little bit before I got into tomorrow night's class. And I hope this has been helpful. This will be a video stored out on YouTube. This will be a video on Twitch. I've got both of those links on my syllabus. And please keep in mind, I know somebody probably take a step back and say, well, he's just trying to make money off this. I am not a monetary streamer at all. I post stuff for my classes that I teach. I teach classes as well elsewhere. And I try to post videos up for folks to have, and I try to stream so we can do online office hours. I do believe in online office hours as a future research direction I would like to go down, because I think it would be helpful in K-12 schools. That's just me. But this is just something I do because I enjoy doing it, and I like having folks come by. And if we get to talking about math at some point, maybe we can take it to a conversation way up here. Maybe talk about some gaming. I don't know. And some research with gaming. There's a lot of good stuff out there. I was reading another one tonight about gaming that talked about GPAs versus those who game, what their GPA is, and those who don't game, what their GPA is. And I was reading it and I disagree with it vehemently, but I need to read a little bit more because I got to find out what their population is they pulled from. It was kind of older too. So anyway, that's all I've got for you tonight. I appreciate all you guys stopping by, and I'm going to note this tonight. I note it every time, whether I offer points or not, because that lets me know who's engaged, who's not in the class. So later on, if you're struggling, I can kind of work with you a little bit more, knowing that you've been trying your best to work through this stuff. So that's all I've got. Again, I was doing Restream through YouTube and Twitch, and I appreciate you guys being here, and I will see most of you tomorrow night in class. And anybody who stops by from the World Wide Web, I'll see you maybe next time. Thanks. Now I got to close out. gotta click there. There we go. All right, take care.